Good morning, good people. Once again, my name is Hendrik Makaneta, and I'm your grade 9 mathematics teacher. And of course, this education is brought to you by STEM Lockdown Digital School in association with a wide range of partners. Now, what is important here is that we need to now check the topic, and of course, at the end of the lesson, please feel free to email me or just to send a Twitter on my account, which is at Hendrik Makane3, just for further information. And of course, what is important now is that we must understand what is the objective, or at the end of this lesson, what is it that we need to have achieved. And of course, by the end of this lesson, we must have achieved the following. We must be able to solve geometric problems, to find unknown sides as well as unknown angles. Always remember to indicate that you are describing an angle by using the angle sign. That is very important. For instance, if you look at the diagram in our list here, we've got the line AB together with the line CB and BD. Now BD and CD are meeting at a point B, and that is where they join with the line AB. And if you can check thoroughly there, you will be able to see that we have created triangles. And of course, the triangles are as follows. We've got angle B1, angle B2, and angle B3. Those are the angles that we have. And if you can check these angles, because they are on a straight line, we say that if you add them together, if you add B1, B2, and B3, you should be able to get 180 degrees. What does this tell us? This tells us that the sum of the angles on a straight line is 180 degrees. That is what you have. The sum of the angles on a straight line is 180 degrees. So that is the sum of the angles of any, on a straight line. The sum of the angles on a straight line is 180 degrees. That is why we conclude by saying B1 plus B2 plus B3 gives us 180 degrees. Now, that is in relation to the straight lines. And of course, we will probably have different angles as well, as reflected in the following. We have got angles here, angle 1, 2, 3, and 4, which are formed when two lines intersect each other. Let's look at the following. When two or more lines intersect at a point, they form what we call vertically opposite angles. The vertically opposite angles are equal. In this diagram, you can see that angle 1 and angle 3 are vertically opposite angles, and angle 2 and angle 3, angle 2 and angle 4 are also vertically opposite angles. Now, we notice that vertically opposite angles are not adjacent to each other, meaning that they are not next to each other. They are just vertically opposite. They are not next to each other like 1 and 2. 1 and 2 are adjacent angles. but 2 and 4 are vertically opposite angles. And of course, vertically opposite angles are equal. That is why we say angle 1 is equal to angle 3. And of course, angle 2 is equal to angle 4. So note that every time you make a statement, you need to back it up with evidence or a reason. You need to provide a reason for your statement. You don't just make a statement without any valid reason. So the reason for saying this angle 1 is equal to angle 3 and that angle 2 is equal to angle 4. The reason is they are vertically opposite angles. That is the reason. We have spoken now about the lines which form angles on a straight line. And we have also indicated that when you add angles on a straight line, you get 180 degrees. And of course, we have concluded that angle B1 plus angle B2 plus angle B3 gives us 180 degrees. And of course, we conclude by stating the reason there, the reason being the sum of angles on a straight line is 180 degrees. That is the reason that we have given. Now, we've also spoken about the vertically opposite angles. And we have said that vertically opposite angles are equal. And in this case, we have given the example here of angle 1 and angle 3. We've equally given out the example of angle 2 as well as angle 4. So those are the pairs of what is known as vertically opposite angles. And vertically opposite angles are equal. And remember that this is the work that you probably started in grade 8 already. And hopefully this is some revision for you when it comes to angles. We are now proceeding to the next category of angles. And we are now looking at 90 degrees. If you look at the first diagram, where the line AB is perpendicular to the line CD, meaning that they form 90 degrees there, you can make a conclusion because that information is given to you. You can see the sign, the 90 degrees sign, which is here in this angle B. That small square there represents 90 degrees. And that is why we say angle ABD is equal to 90 degrees. And what is the reason for this? Because the line AB is perpendicular to the line CD. And that is the sign of perpendicular. You can see that it shows a line joining another line, and they form 90 degrees. And this is given to us. In the same note, angle ABC, which is the angle just adjacent to ABD, that angle is also 90 degrees. Because AB, as I've said, is perpendicular to CD. That is what we have at this point. ABC is equal to 90 degrees because AB is perpendicular to CD. And the next one here, you'll have the line EF, which is also perpendicular to the line GH. This means that where they meet, where the two lines meet, an angle that is formed there is 90 degrees, as reflected on the diagram. You can see that angle EOH is 90 degrees. You can see the small square there. That small square means that the size of this angle is 90 degrees. And what is the reason? The reason being EF is perpendicular to GH. That is our reason. EF is perpendicular to GH. In the same note, we will be able to see here that angle EOG, this angle which is just now adjacent to angle EOH, that angle is also degrees. I hope that it makes sense. I hope that it makes a lot of sense. Now, as we proceed to the next slide, we do realize now that we need to calculate or use the information that we have learned now to calculate the value of the X there, the missing value of X. Now, in the first category, you should be able to see now that we have a straight line and we have got two angles there that are formed in a straight line. So there's a line that that meets with the first line where the two angles are formed on a straight line. And as you know now, we already know that when you add X and 55 degrees, once you add these two, they should be able to give you 180 degrees. These two angles should give you 180 degrees. And now, what will be the value of X in this instance? What will the value of X be in this instance, where you need to find X? How are you going to find X? This means that you'll have to say 180 minus 55. And 180 minus 55 gives you 125. So in other words, the value of X in the first category there will be 125 degrees. That is in this case here. So the value of X will be 180 degrees, will be 125 degrees. And how do we get 125? You subtract 50 from 180 And why do we subtract 55 from 180? Why do we subtract 55 degrees from 180 degrees? That is because the combination of these two angles, x and 55 degrees, if you add them together, they will give you 180 degrees. And that is why you find x by saying x will be equal to 180 degrees minus 55 degrees. And of course, that will be 125 degrees. And in the same note now, you can go to the next diagram, and you should be able to see that we now have vertically opposite angles. We now have vertically opposite angles. Now we no longer talk of adjacent angles. So the sum of x and 95 will not be 180. Why? Because those are vertically opposite angles. And we have just learned about vertically opposite angles this morning. And what did I say about vertical opposite angles? If you remember very well, just to take you back to the slide where we spoke about vertically opposite angles. We spoke about vertically opposite angles this morning, and we said that the vertically opposite angles are equal, as reflected in the slide. Now, you must be able to use this example to solve the next activity which we have by remembering that vertically opposite angles are equal. Now, we have x, which is vertically opposite angle, and it's vertically opposite 95 degrees. Then we can make a conclusion that the value of x will be 95 degrees. And what is the reason? The reason is vertically opposite angles. So angle x is equal to 95 degrees because those are vertically opposite angles. Then we proceed to the next activity there, which you can clearly see that we have got a straight line in the first category there, number 3. This is the straight line. And in this straight line, you have 45 degrees, you have x, and you have 40 degrees. So these 3 angles here are on a straight line. You can see the straight line that we are now talking about. The 3 angles are on a straight line. And what is the straight line? The straight line will be the line that is moving from the left towards the right in a vertical way. Now that line is a straight line, and 3 angles are formed out of that straight line because we have got 2 other lines which are joining this line. So the joining of these 2 lines give us 3 angles. The first being 45 degrees, x degrees, and 40. Now, obviously, when you add 45 degrees and 40, they will give you 85 degrees. And if you subtract 85 from 180, you'll be left with 95 degrees. So therefore, this means that your x value there will be 95 degrees. That will be 95 degrees, because you have added now all the angles on a straight line. And of course, that is the principle of the straight line which we spoke about earlier on. And yet again, if you look at the fourth one as well, you should be able to see that we have a 2x here, which is adjacent, an adjacent angle to 90 degrees. And that is information that is given. You are told that the adjacent angle here is 2x, and its adjacent angle there will be 90 degrees. To an extent that we know that these two also form 180. But if this one is 90, if this angle here is 90 as reflected with the square, then 2x will also be 90 degrees. But what are we required to find? We are now required to find x and not necessarily 2x. Now we know that 2x is equal to 90 degrees, because this 2x is an adjacent angle. And of course, if 2x is 90 degrees, therefore, what will be the value of x? X will be 45 degrees, because 2 times 45 gives us 90. So the value of x here will be 45 degrees, because 45 times 2 gives us 90 degrees. And then we carry on now to the next activity 5. You can see that we are given some angles here. We have got 30 degrees, 50 degrees. We also have unknown there, which is x. And how are we going to find the value of x? How are we going to find the value of x? Very simple. In order to find the value of x, you need to realize that there's a straight line here, which also forms about 3 angles on this side. The angle, where the arrow is now, that's the first angle, followed by the second angle, which is 50 degrees, followed by the third one, which is 30 degrees. So you have 1, 2, 3 angles on a straight line. And we know by now that the angles on a straight line give us 180 degrees. What does this tell us? If you add 30 and 50, you get 80 degrees already. So this tells us that the next angle will be 100 degrees. And if this angle is 100 degrees, then, excuse me, x will be 80 degrees. That is one aspect. That is one way of doing it. You can find the missing angle here, which is 100, and then you know that the adjacent angle will be 80. But that does not end there. That is not the only way in which you can find the value of x. You can still use the vertically opposite angles. You can see that the 2 lines which form an x there, x is vertically opposite to 30 plus 50. So those 2 angles there, both of them are vertically opposite to x. So this means you can conclude that x is equal to 80 degrees, and the reason being vertically opposite angles. That can be your reason. And of course, we can proceed to the next one now, and I hope that I'm not fast. Let's proceed to the next one. If you look at the next one here, you have 70 degrees, and then you've got x. You also have 10 degrees, and you've got y. Now, if you look at these pairs of angles, x plus 70 must give you 180 degrees. Why? Because those are angles on a straight line. In the same note, y plus 10 must also give you 180 degrees. And the reason being, they two are on a straight line. So they are angles on a straight line. Now, how do we add them together now? How do we find the missing angle? Very simple. Let's start with x. We know that x plus 70 gives us 180 degrees. So what will be the value of x? So by inspection, you can see that the value of x will be 110 degrees. Because if you add 110 and 70, you get 180 degrees. If you don't want to do it by inspection, you can use now the equation there. You can say x plus 70 is equal to 180 degrees. And the reason being, those are angles on a straight line. And thereafter, you can transpose your 70, and you can subtract 70 from 180. And 180 minus 70 is 110. So therefore, x will be 110 degrees. And that is in number 6 then. And the same goes for y. In the same way that you found the value of x, you will use the same principle to find the value of y. And indeed, the value of y will be y is equal to 180 degrees minus 10 degrees. So you have to subtract 10 degrees from 180. And of course, if you subtract 10 from 180, you'll be left with 170 degrees. So therefore, the value of y will be 170 degrees, whereas the value of x will be 110 degrees. So this, we have used now angles on a straight line to solve for the missing values. That is in number 6. But equally, we have used vertically opposite angles in number 5 there to find the value of x. We are proceeding now to the next slide, where we will look at number 7 and 8. Now, if you look at this slide, we have several angles in number 7 there. We have got about 5 angles. 3 unknown, 2 knowns. The unknowns and the knowns. What are the knowns? The known angle here, the known angles are 2. We know 140 degrees and 110 degrees. Those are the angles that are known. What are the unknowns? We've got y there, we've got x. We also have y here, which I believe should have been z. So that we have x, y, and z. But of course, let's look at the first one here, this one. And perhaps it will become clearer why do we also have y there? In this case, we know that y and 140 are angles on a straight line. These two angles are angles on a straight line. And how do we solve angles on a straight line? We should know by now that angles on a straight line form 180 degrees. And of course, when you add them together, y plus 140 degrees must give you 180 degrees. Why? Because they are angles on a straight line. This means that the value of y will be 40 degrees because we already have 140 on the other side. And of course, if you add 40 and 140, you get 180 degrees. And that is what you get. 180 degrees, that is what you get. So therefore, the value of y will be 40 degrees. Now you are also told that this value here is also y. Now what does that tell us? Now that we found y, the value of y here to be 40, then you can substitute it here in this angle y there, meaning that you'll also have 40 there. And of course, if you look at this y here, the second one, and the x plus 110, those are angles on a straight line. And of course, angles on a straight line form 180 degrees. We have proved that y is 40 degrees by looking at the previous example there. Y plus 140 is 180, therefore y is 40. So even this y here will be 40 because y and y, those are the same angles. They're equal. So in this case, you need to add x, y, and 110 to get 180. But we already know that y is 40. So if you add this y here and the 110, meaning that if you add 40 and 110, 40 plus 110 gives you 150 degrees. So these two angles here gives you 150 degrees. What does this tell us? This tells us that the last angle there, which is x, will be 30 degrees because these three angles are angles on a straight line. The sum of the angles on a straight line is 180 degrees. That is why the value of x there will be 30 degrees. Why is it 30? Because we already know the value of y, which is 40. 40 plus 110 is 150. And to complete these angles, to make it 180, what do you add to 150? You add only 30. So this means that x will be 30 degrees. And of course, you do the same with the next 8 there. Number 8, you can see we have angles on a straight line. We also have vertically opposite angles. Let's start with x. Let us start with x. You can see that x and 25 are vertically opposite angles. And what did you say about vertical opposite angles? We said that vertically opposite angles are equal. This means x is equal to 25 degrees. That is what we can see in this diagram. X and 25 are vertically opposite angles. And what did we say about vertically opposite angles? We said that vertically opposite angles are equal. But at the same time, you can also see that angle Y there and angle 140 degrees, those are also vertically opposite angles. And what does this tell us? This tells us that angle Y is also equal to 140 degrees. And the reason being, vertically opposite angles are equal. Therefore, Y is equal to 140 degrees. The last one, which is Z, you can see that Z is on a straight. Those are angles on a straight line. And of course, angles on a straight line form 180 degrees. We can see that angles on a straight line form 180 degrees. And of course, if you add 140 and 25, this should be able to give you 165 degrees. They add 165 degrees. And if you subtract 165 degrees from 180 degrees, you'll be left with 15 degrees. Therefore, the value of Z will be 15 degrees. And of course, this has shown that we have been able to use angles on a straight line as well as vertically opposite angles to find the missing angles. That is the principle that I wanted us to look at today. We have now covered angles on a straight line. We have equally covered angles on vertically opposite angles. And I believe that the two concepts should be able to help you as we move forward with our activities. Vertically opposite angles are equal, and the sum of the angles on a straight line is 180 degrees. Now, I would have wanted to give you an activity, but before we get there, we need to look at the intersections. Where two lines meet, we call that an intersection. That is where the two lines meet. Just like the streets, where the streets meet. If you're walking down the street and you come across another street, they form an intersection where they cross each other there. Sometimes you see there's four-way stop. The stop sign will be there to show that you need to stop and wait for the next car. That is an intersection. So even in mathematics, the lines where they meet, we have an intersection. And the line that crosses two other lines, just as in this case here, we call it a transversal. So a transversal is a line that intersects two other lines. You can see the first point of intersection at the top there, and the second point of intersection at the bottom. So these are the lines that we will talk about. And these lines also give us angles. They form angles where they meet. Angles are formed in intersections. some of the angles that are formed there will be angles on a straight line. But at the same time, you will also have vertically opposite angles which are formed. But of course, you will also have new angles now that are formed, which we are going to talk about. I believe we cannot do justice in this lesson to talk about all the angles. For today's lesson, we've learned about the angles on a straight line. We've also learned about vertically opposite angles. And perhaps in the next lesson, we should be able to look at the alternate angles, which are formed when a transversal, remember a transversal is a line that intersects or cuts two other lines. So the angles on the different intersections on different sides of the transversal are called alternate angles. They point in different directions. Someone can say they form a Z shape, as you can see in the structure there. They form a Z shape. And of course, if you carry on, you should be able to see that we also have corresponding angles. And these corresponding angles are also formed as a result of the transversal. That is the line which cuts two other lines and form intersections there. You can see that the corresponding angles are not the same as the alternate angles. If you look at these diagrams carefully, you can see that these corresponding angles form an F shape. And these are the angles that we will thoroughly look at as we proceed with our lesson. And of course, you will also have co-interior angles. That is angles that are formed and are inside, they form a U shape. You can see that co-interior angles form a U shape. And the key word co-interior, those are the two interior angles on the same side of the transversal. So they are on the same side of the transversal. The transversal being the line that intersects two other lines. Could be two or more. Corresponding angles, as we have said, they must be on the same position in each intersection. They form what we call an F shape. And then, of course, you have an example here which I believe we will not be able to exhaust. In this diagram, you can see that the line AB is parallel to the line CD. And this indicates that AB is parallel to CD. You can see with the sign there, which angles are equal to each other, and give reason for your answer. I can already see that we've got quite a number of angles that are equal to each other there. I can see angle 1 is equal to angle 3, angle 2 is equal to angle 4. And those are vertically opposite angles. So I want you to take this diagram, this example, and list the other pairs of equal angles in this diagram. And you can use the angles that we have learned. You need to now expand it, move from angles on a straight line, because 1 and 4 are angles on a straight line. They are not equal, but their sum is 180 degrees. But if we want to talk about equal angles, we'll look at vertical opposite angles, we'll look at alternate angles, corresponding angles, as well as co-interior angles. Because today we've looked at those. And of course, we can carry on with the next lesson to check. But if I were to give you the answer to this example, you should be able to see that angle 4, as I've said, is equal to angle 2. And those are vertically opposite angles. And of course, angle 1 is equal to angle 3, and angle 5 is equal to angle 7. And those are vertical opposite angles. And of course, angle 8 is also equal to angle 6. So for today, I will just wrap up my lesson here. And tomorrow, we'll just be able to carry on just to also use these different angles in practical examples. So you will look at these answers carefully. Those are the answers of the previous slide here, the example that I had. But unfortunately, time is not on our side. Therefore, we've come to the end of our lesson. And let's carry on with the different angles tomorrow when we meet again at this time. Until we meet tomorrow, thank you very much indeed. Have a good day.